Hey y'all, what you gotta say? Hanging out with Kalodi today. What's up, everybody? Welcome to day 4 application problems of the laws of sines and the law of cosines. Law of sines and the law of cosines. So what I did was I put it in a nice easy box to review. When is the law of sines most easily used? Well, it's most easily used when you're given two angles and a non-included side, or if you're given two sides and a non-included angle. So, and that this two sides and a not included angle, that was the whole ambiguous case thing that we worked on day number 2. Law of cosines, which we did on Monday, is most easily used when you're given two sides and an included angle, or if you're given all three sides. So I have 4 application problems that we'll go over, and let's determine which one might be easiest to use, which law might be easiest to use. So sides of a parallelogram are 4 and 6. One of the angles is 55 degrees, while the other is 122 degrees. Find the length of the diagonals. So just to draw this here, I happen to take the liberty of, already drawing the parallelogram. Notice I drew sides of 4 and 6 and the angle of 55 degrees and the angle of 122 degrees. Let me go back and try to do this in red. It wasn't doing it in red before. There we go. So that's in red. And then let me use my moon pen. I call this the moon pen because it's so starry. I'll do the other diagonal right here. So how can we find the lengths of those diagonals? Well, if you think about it, we could just consider this two different triangles. While I have the moon pen out, let's have one triangle right there. And I also took the liberty of just labeling the parallelogram ABCD. And then if I go back to red, this is another triangle right here. So they both share that side of 6 on the bottom and going through. So if I separate this into two things, let's work this on through here. So let's write this first triangle right there. This is angle A, B, D, and this is a 6, this is a 4, and that's 55 degrees right there. And I guess we're trying to find side A. And if I get my moon pen out, this is the other triangle. Right there, and right there. This is the 122-degree angle. This is the 4. This is the 6. And this is side D right there, if you think about it. That's C, and that's A. And so I guess we're finding side lowercase d. Okay. In both cases, it looks like we are given side, angle, side. In other words, side, the angle, the included angle on the side. So what does that lend itself to? That lends itself to the law of cosines. So that's what we're going to use in both of these cases. All right. So since I'm on the 122 over here, I'll use the moon pen first. Let's find d squared. So d squared is going to equal the one side squared plus the other side squared minus 2 times the first side times the second side times the cosine of the given angle. Notice I didn't bring up the law of cosines. It's fairly straightforward. It's the side you're looking for equal to the other two sides squared minus 2 times the other two sides times the cosine of the opposite angle. All right, so if I work that through, d squared on my calculator turns out to be about 77.436. I take square roots on both sides, and I get d equaling roughly 8.8. And as Bon Jovi says, we're halfway there. Now let's find side A. So a squared is going to equal 4 squared plus 6 squared. It's a square, by the way, sorry. Minus 2 times 4 times 6. This time times the cosine of 55 degrees. If I work out a squared and work it all out, work it out on your calculator. Don't just take my word for it. You get roughly 26.56387. Good news is, when you do all this work, you don't have to round it off. You could just get the answer and then take the square root of the answer on your calculator and get A equal to 5.2. So I found the lengths of the two diagonals. Huzzah! There we go. Rewind, replay, do what you need to do, and answer those questions. Two ships have a harbor together, traveling on courses that have an angle of 135 degrees and 40 minutes between them. If they each travel 402 miles, how far apart are they? All right. So let's start off by drawing the picture over here. Apparently they have a pretty big angle between them. They're going, you've got two ships leaving from the same port. One ship's going this way. Other ship's going this way. They're both 402 miles, but let's get to that. First, they have 135 degrees and 40 minutes between them. And they both have traveled 402 miles. We are trying to find this distance, let's call it x, between them. Once again, I've got two sides that happen to be equal sides. We'll get to that in a second. What kind of triangle is this? And an include angle, that's side, angle, side again. That's the law of cosines if I ever saw it before. All right, so let's get to it. X squared equals 402 squared plus 402 squared minus 2 times 402 times 402 times the cosine of the 135 degrees and 40 minutes. If I work that on through, x squared is going to be roughly a big number, 554,397.2516. Take square roots on both sides, and I get x equal to 744.6. And we're talking about miles here. Now, I'm going to put a little, I'm going to box up this work, and I'm going to put a little note. Even though we were given side angle side, we could have used the law of sines here. Does anybody see how we could have used the law of sines? What type of triangle is this? Since this is an isosceles triangle. That's right. Oops. Let me erase that right there. Since this is an isosceles triangle, we could have used the law of sines to solve this problem. And you could have done that by finding the other two angles. Think about it. Just subtract 180 from 135 degrees and 40 minutes, then divide by 2, and you got the other two angles. Just saying. All right, so that said, law of cosines seem to be, and look what I wrote up here, the most easily used method. All right, as I always say to my classes, there's always more than one way to eat a Reese's. And so you could have solved this using the law of cosines or the law of sines. Example 3, a ship is sailing due north. The captain notices a lighthouse 12 kilometers distant on a bearing of 38 degrees 50 minutes. Later on the trip, he notices that the bearing of the lighthouse is now 135 degrees 50 minutes. How far did the ship sail between sightings? Time out. This question looks and seems so familiar. It looks and seems so familiar. It's almost as if we've seen it before. I don't know where. Right here. Look at that. It's the exact same question which we did on the Unit 14 Day 1. It was a Law of Sines lecture. Holy moly guacamole. Yeah, I know. I just gave you the same exact problem. So you know what? Instead of doing this problem all over again, here's what I'm going to do. Magic of the computer screen. I am simply going to control paste this sucker. Oh my gosh, and the work even shows up. How cool is that? All right, that's cooler than the other side of the pillow. So I'm going to have you look at that, review it. You can pause this video and stare at that and understand what the heck I did for as long as you need. Meantime, I'm going to go to example number 4, our last example in this lecture. A weight is supported by cables attached to both ends of a 90-foot balance beam. The lengths of the two cables are 45 feet and 60 feet. What angles are formed between the beam and the cable? So we're finding two angles here. So let me draw a triangle here. I don't know why the angles wouldn't be the same. You know what? Here, let me erase that right there. Let me try this again. Sorry, I didn't mean to erase that whole thing. All right, so one is a little bit shorter, one is a little bit longer, and I'm not making this happen right here. I know why I'm not making this happen, because the angles I'm making are basically the same. There we go. All right, so here's the beam right here. Let's call this triangle A, B, and C. And let's make this the 45. Since that looks like the 45, let's make this the 60. And let's make this the 90 right here. Okay, so we're trying to find angle A, and we're trying to find angle B, because this is the weight that is dangling right there. So I see that we are given side, side, side. So once again, that's the law of cosines. All right, so to find angle A, we're going to use a squared. What angle A is a squared equals b squared plus c squared minus 2bc times the cosine of angle A, which is what we're looking for, angle A. So a squared is the 45 squared equals b squared, which is the 60, c squared, which is the 90, minus 2 times 60, so times 90 times the cosine of A. I will go through the majority of the work with you here on this one right here. Okay, so working this on through, this is going to be 2025 equals 3600 plus 90 squared, 8100, minus 2 times 60 times 90, which is 10,800. Cosine A. I know, continuing to work this way through right here. All right, so now just cutting to the chase a little bit. If I add up the 36 and 8100 and then subtract it over, I'm going to end up getting negative 9,675 equals negative 10,800 times cosine of A. I divide by negative 10,800. Negative 10,800 is here as well. Negatives cancel. And if I take the arc cosine or the inverse cosine of that, and of course the arc or the inverse cosine here, I'm left with angle A equaling 26 degrees. I'm sorry, 26.4 degrees. Okay, great. We're halfway there once again. Now all we need to do is find angle B. So B squared equals, you know what, I'm just going to get right to it right here. So let me erase that right now. You know what, I've done it. I'm going to start. B squared equals a squared plus c squared minus 2ac times the cosine of angle B. Plug in and get 60 squared equals 45 squared plus 90 squared minus 2 times 45 times 90 times the cosine of B. And to go through the exact same process, angle B is going to end up equaling 36.3 degrees. So there are 4 application problems. I hope you found them helpful. If you have any questions, please email or message me. We'll see y'all later.